Hello, everyone. Today, I'm going to introduce lab electrical instruments. We're going to do virtual lab. Virtual lab means that on your screen, you are going to create electrical circuits and do the measurements with virtual meters and voltmeters. This is introduction on how to do it and how to connect everything and how everything is working. So if you click on the link, which I provide in Canvas, in instructions, you are going to get to the page of Colorado University in Boulder and concentrates lots of physical simulations. We are going to get one of them, Circuit Construction Kit DC. Link is going to bring you right to this page. So what you do next, you click on the arrow. When you click on the arrow, it's going to start the program working. We are going to click on intro. Actually, I don't see big difference between intro and the lab, so I'm clicking on intro. That's the screen you are going to see when you click on intro. So let's see what panels we have here in our virtual lab. First, there is a panel of all available elements of a circuit. For example, we do have wire, battery, light bulb, resistor, switch. We have more. We have, for example, fuse, dollar bill, paper clip, coin, pencil, razor, hand, and a dog. So guys, a little introduction. Normally, circuit consists out of several elements. And first is going to be the battery. How do we construct circuits here? We pull the battery from the panel to blue screen. The battery is over here. If you click on the battery, you can change voltage of the battery. We are going to use a standard voltage, which is already set as 9 volts. So you don't need to change anything here. Now, we'll need an element which is going to show us that the circuit is working. I'm going to choose a light bulb. Light bulb is going to be my element which shows me that the circuit is working. So to make a circuit, we'll need to connect all elements together. We are going to use wires to do this. To connect wires, you just need to bring the wire next to the element, and then like this, red dashed circles are making connection. Well, I don't want to mess wires all together, so I'm going to connect a little bit more wires that actually we need. So I'm going to connect, like make more complicated connection here. You see that I connect here 2 wires. Could do it with 1 wire, but I'm doing it like 2 wires. And my next one is going to be connected over here. So now you see the circuit is connected. You see little blue circles running around the circuit, and you see that bulb is kind of like lit. Little blue circles are electrons. You see over here on this panel, it tells show current, and electrons are turned on. I'm going to turn the conventional current. Conventional current actually is not current of electrons. Electrons are negative particles. Conventional current is current of positively charged particles. And you see that current goes in opposite direction over here. If you don't want to see the current, you can just turn it off and there is no current anymore. Okay, I'm going to go back to electrons. It shows me that like my circuit is working. If I disconnect a wire, usually you just click on the wire and put on scissors and you disconnect it. You see that electrons stop moving. The circuit is not connected and the current is not going to flow. So the first rule here is to connect all elements together. Broken circuit is not going to work. What else do we need to know? For all elements, not only for batteries, we can actually change the resistance. Resistance is like, well, let's see. I'm going to click on the bulb. You see that resistance of the bulb is 10 ohms. I'm going to increase it. You will see what happens to the bulb. Okay, let's make it like 20. You see that the bulb with greater resistance is not that bright. We are not going to use the bulbs for actual lab, but you can experiment like how everything is working. And you can also put something else, not the bulb, but dollar bill over here and see if the circuit is going to work. Play a little bit with it. Okay. All elements can change resistance using like by clicking on element and seeing resistance panel. Okay. What else do we need to know? Well, we are going to measure certain quantities here. The first one is going to be the voltage. to measure the voltage, we are going to take the voltmeter. Voltmeter looks like this. The voltage is written on it, right? There are two probes. And voltage actually shows like the potential difference between 2 points in a circuit. I'm going to measure voltage across a battery. You see that it shows 9 volts. Now I'm going to measure the voltage across the bulb. It's supposed to show me same 9 volts across the bulb. Just let's see if it's going to do it. Yeah, it shows me 9 volts. If I want to measure voltage across a wire, which we are considering ideal wires with no resistance, you see what is going to happen. Just let's connect it. You see that the voltage across the wire is equal to 0. So only elements are producing a voltage drop in our experiment. Now, guys, one more element we'll need for this lab is ammeter. Ammeter is measuring current, or how many electrons are flowing along the wire and how fast they are doing this, right? How do we use ammeter? You see that it's not written ammeter on ammeter. It's actually telling the current. Well, it's going to be okay for us. We are just going to put this crosshair and on the wire, and it's going to show us the current. The current here is 0.45 amperes. I'm going to check the current over here now, and it's still same. And over here now, it's still same. And can I check the current over the battery? It's still same. So in the circuit, in the one loop, the current is going to be same everywhere in this circuit. Okay, so that's introduction. That's how everything is working. So it's not actually lab. I suggest you to work a little bit with it, play with it before you do the lab. Now I'm going to explain what we're supposed to do in actual lab. Give me a second, guys. I want to make a little break and then go back. Okay, guys. So we are going to start our experiment. For the first experiment, we are going to connect a circuit in series. In series means that we are going to have a battery, wire, wire, resistor, wire, resistor, wire, another resistor, and two more wires. Wires are sitting here, right? Resistors are looking like this. Like they look like wires, but they have like colored lines on them. Okay, we're not going to use bulbs. They're too big and not very nice looking when you connect them. So we are doing in series means that they look like a little train, right? Card 1, card 2, card 3, and the engine. Okay, you see the current is moving around, right? What I want you to do, guys, I want you to set up the first resistor to 10 ohms. If you click on it, you're going to see how to change resistance here. You move this slider and you're going to change it to a different resistance. I want you to set up the first one to 10 ohms, like I have right now. Well, it's 11, doesn't want to be 10. Okay, let me. 10. Okay, second resistor is supposed to be 20 ohms. And the third resistor is supposed to be 40 ohms. What are we going to check for this circuit? First, we are going to check that the current is same everywhere in the circuit. How are we going to do? First, we are going to take the probe for the current, and we are going to put it across this wire. Or you can put it across the first resistor. You see, 0.13 amperes. Now I'm going to put it across the second resistor, and it's the same, right? And put it across the third resistor, it's the same. You're going to write them down, record them as 3 different currents, but they are all supposed to be same. And you can check the current through the battery, and that's going to be same. So we checked that the current in a one loop circuit series connection is same everywhere. What is going to happen to voltages? The voltages are going to have slightly different rule. Let's check the voltage across the first resistor. You see, you don't need to move voltmeter, you just move the probes. And it's 129 volts, right? And then you check the voltage across a second resistor. You record it as voltage 1 first, and this one as voltage 2. And the next one as voltage 3. What is interesting, sum of all voltages across resistors must be equal to net voltage across the battery. You record it as a voltage across the battery. We remember that we set it up to 9 volts and it's 9 volts, okay? So these are like 6 numbers you are going to collect from the first part of the lab. three currents, no, four currents actually, current 1, current 2, current 3, and current of the battery, and voltage 1, voltage 2, voltage 3, and voltage of the battery. The rest is going to be just calculations, which I'm going to explain in a worksheet. What else? Well, you guys probably see that the voltages are different across different resistors. You probably see that voltage across the bigger resistor is bigger. That's going to be called Ohm's law, and we are going to check it too. Well, now I'm going to make a short stop and connect a different circuit, circuit where resistors, the same resistors are connected in parallel. I don't want to spend your time on like showing how I connect it. It's not very difficult to do on your own. So I'm going to stop it and start it again when the circuit is ready. Okay, guys, I prepared my circuit for the second experiment, parallel connection. You see that I do have 3 resistors and a battery, right? Resistors are same ones, 10 ohms, 20 ohms, and 40 ohms. The battery is same, 9 volts. The difference is that they connected differently, right? How they connected? They are connected in parallel. Before they were looking like a little train, right? Now they are looking like a bunch of parallel lines. Battery parallel to it, first resistor, second resistor, and third resistor. What are we going to check in this circuit? You see that electrons are running, and these electrons are running faster, the top ones, right? And the electrons lower are running slower, and this one are the slowest. Actually, that's because the resistance here is greater than resistance here. So the current depends on resistance. We remember Ohm's law, right? What are we going to check in this circuit? Well, we are going to start again with current. What are we going to check? We are going to check the current through the first resistor, through the second resistor, and through the third resistor. Record all the numbers. Then we are going to check current through the battery. So 4 different currents, okay? You see that all 4 are different. Why? Because current actually flows from the battery and splits between resistors and goes current 1, current 2, and current 3. Some of these currents, current 1, current 2, and current 3, which is I1, I2, and I3, are going to make up the current through the battery. Okay? It's like a river which splits in 3 branches. What is going to happen to the voltage? Well, let's check. We remember that voltage across the battery is 9 volts, right? Let's double check it. Is it still 9 volts? Yeah, it's still 9 volts. Now let's check the voltage across our first resistor. You see, and it's still 9 volts. And across our second resistor. And it's still 9 volts. And across our third resistor, it's still 9 volts. What do we see? We see that in parallel connection, voltages are same across all 3 resistors because they are connected to the battery, and battery is kind of considering these circuits as separate loops. So loop number 1 is one circuit, loop number 2 is a second circuit, and loop number 3 is a third circuit. They kind of don't know about each other. So here, what do you want to measure? Well, 4 currents and 4 voltages. Just before, the currents were same and voltages were different. Now the voltages are going to be same and the currents are going to be different, right? We are going to do some calculations with those voltages and currents, but that's what you will need to kind of record from the lab. And that's going to be it. It's not supposed to take more than like 15 minutes to do the lab, and you can plug in different elements, see how everything is working. That's a nice lab actually. Okay, I'm going to stop my video at this point. And the calculations are going to be provided below, the calculations which I want you to do. Okay, that's it.